Hello, everyone. Thank you for coming by. So my name is Wang, and I'm actually an engineering manager on Airbnb data platform now. So today I want to talk to you about Spark at Airbnb, and we'll talk about a few major use cases for Spark, and I'll also share a little bit of learning experience from upgrading to Spark, the latest Spark version. And at last, I'll share a deep dive of one particular use case using Spark for data ingestion. So what is Airbnb? Essentially, Airbnb is a two-sided marketplace for short-term rental and stay. So people can list the homes and the rooms on Airbnb, and while you travel, you can also rent these homes and the rooms to stay. So what I'm showing you here is like in 2009, there were just some listings in the United States, and 10 years later, we have 6 million homes worldwide, and some big numbers as usual. So we have different types of listings: entire home, private rooms, shared rooms, and also like vacation homes, and some unique homes. So a few years ago, we also started a new thing called Airbnb Experiences. So when you travel to a place, you want to connect to local people and local culture, right? So experiences are activities hosted by local people, and to having these different activities with guests. So some examples here, and some more examples. So what does that mean for data infrastructure? Of course, it's tremendous amount of growth for the data size. So what I'm showing you here is the size of our data warehouse in the last 2 years. The years before were even more dramatic. I'm not showing you that because legal doesn't really like me to give out too much information. So, with all this data growth and the huge amount of data, Spark is the tool to best fit for this kind of jobs, right? Either data transformation, data analytics, machine learning, and all of that. So I'll talk about a few use cases on how we use Spark. The first one is the search team is basically building different kind of machine learning models to serve the search results on Airbnb.com. So they need to prepare the data for training the model and to prepare the features for scoring, and they are using Spark for that. There are two particular reasons they like Spark for this job, because first of all, with Spark, they can write complex error handling and also unit test to make sure the search data we prepare for those models are correct. And the second thing is that most of the microservices at Airbnb are built using Java. So they are able to share the code base between the online systems and the offline data pipelines, because they are all written in Java and Scala. And there are also features in Spark SQL like broadcast join that can be very useful in some cases. And if you're interested in this, they have an archive paper. Feel free to take a look. And another use case for Spark I want to talk about is smart pricing. So smart pricing is a feature we provide to hosts. So when they list a home or list a room on Airbnb, many of the hosts doesn't really have the full information about the state of the market. So they could really use some help to set the price accordingly. So we came up with this feature that basically help the host to set the price using machine learning models. And again, to train these models and for scoring, we need to prepare a lot of data. And the pricing team is also using Spark for this use case. And we have a blog post. If you're interested in the details, feel free to take a look again. Another use case I want to mention is financial intelligence. So the financial infrastructure team basically needs to process all the data, pretty much everything in the company. And a lot of that will be data with different quality and cleanliness. And they have to go through pretty much the entire data set with all the transactional history to provide clean financial data and reporting to power different various business functions. So they built this entire Bravos pipeline on top of Spark. So as I mentioned to you, these major use cases across Airbnb are using Spark, but many of these Spark jobs were created at a different time point, right? So some of them were created years ago, and we have seen many jobs still running Spark 1.5, 1.6, and Spark is now 2.4. So we worked with these teams to upgrade all of these jobs to Spark 2.3, and there are many benefits to the latest version of Spark. If you go read the Spark release notes, it will become very obvious. So the most important thing I want to mention today to you is that basically we are seeing a huge improvement to performance. For example, in one production job, we are seeing 60%, one production Spark streaming job, we are seeing 60% reduction of the batch processing time. So with that, basically, we will be able to reduce the cost, and the job is more scalable and is more performant due to this upgrade. So I would say it's totally worth the time to do the upgrade, although it's very hard to convince people to do that. So next, I want to talk about using Spark streaming for near real-time data ingestion at Airbnb, and the challenges we have seen, and how we solve those challenges. So this graph shows you the logging data flow, or the flow of logging events through Airbnb systems. It's not something unusual, I guess. The logging events are emitted from multiple places, like microservices, monorail, or different clients, and they all being published to Kafka. After Kafka, we have this pipeline called streaming ingestion based on Spark streaming that basically ingest all the Kafka topics to the data warehouse. So streaming ingestion is very important to Airbnb because it's essentially the bridge between online and offline data. It makes it available for everyone in the company to be able to run complex analytics and machine learning on top of this data. It's mission critical to Airbnb, and it's near real time, and it's ingesting hundreds of Kafka topics with really high throughput. And because of the criticalness of this job, we have a really tight SLA. When something goes wrong, it needs to recover very quickly. Because it's a large-scale job, there is also consideration in efficiency and cost. So it cannot be perfect. We have seen many challenges and the pain points with this system. First of all, we are seeing really fast growth of data in Kafka. The topics has grown from dozens to thousands, and the bytes of data in Kafka has grown 6 times in 2018. All of this really poses scaling challenge for us, and because of that, we are seeing bottlenecks in different parts of this pipeline. So one example is in the Spark Kafka Reader, which I'll talk more a little bit later. And the last thing, or the last challenge we are seeing is basically the skew in the event size and the QPS among all the Kafka topics. So some Kafka topics have really high QPS, some has very low QPS, And the size of average events in Kafka is also like, varying a lot depending on the topics. So this box plot shows you the size of logging events by Kafka topic. So as you can see, most of the events in those Kafka topics are between 1 to 2 kilobytes. But if you look at the extremes on the top of this graph, those are almost 2 magnitude larger than the average ones. So when we're using Spark streaming to ingest those events from Kafka, the original Spark Reader, the original Kafka Reader in Spark basically used the model of one Spark task reads from one Kafka partition. As you can see, if some topics has very high QPS, has very large event size, and some has small QPS and event size, it could be really a problem. So some of you are probably very familiar with graphs like this, right? Some tasks can finish very fast because it's reading very small number of events, or the data size is really small to read. But for some other Spark tasks, it can take really a long time to finish the reading. So that's a particular problem because the stage for this particular job has to finish before you can move on to the next. So a lot of resources are wasted in this case. So yeah, that's again a quick summary of the challenges and the pain points. It really affects the stability and the SLA because the streaming ingestion from Kafka depends on HBase, Hive, Kafka, Airflow for scheduling. So it depends on many systems, and any of them having some problem, the job will be affected. And because of it's very critical to the company, so we wanted to catch up as quick as possible. So what we have seen in the past is basically because of the scale, the growth of the scale, the SLA has been suffering, and there were a lot of operational nightmares. Our on-call have to basically wake up in the middle of the night to fix those production issues, which naturally leads to on-call burnout for the team. And again, a lot of resources were wasted, so it's not a really efficient job, and we're paying a lot of money for this job. So the Spark community has recognized this issue, and there were PRs trying to address this issue, but unfortunately it's not merged to the master branch yet. And also those PR does not really handle the data skew problem. So what we came up with is something called balanced Kafka Reader. Let me walk you quickly through that. So comparing to the original model of reading from Kafka, since we are doing data ingestion, we don't really rely on the order of events. So there is very little processing in this Spark streaming job. What it does is basically reading from Kafka and then deserialize the event. So with that, we can actually modify the model a little bit. So for each Spark task, you can just read a subset of the particular Kafka partition. And with that, we can increase the number of Spark tasks. So how do we actually assign the partitions to the Spark tasks? So this is a simple algorithm. Balancing partitions is an NP-hard problem. And there are existing algorithms for approximate solution. But when I look at this problem, I feel like in practice, we don't really need those complex algorithms. There is something simpler that can be more than enough in practice. So this is how it works. So we first compute the average event size for each Kafka topic. And then we compute the ideal bytes per split or per Spark task. And if there is a new Kafka topic, then we use the average size of all the topics. So this is the first step. We have the ideal bytes per split that we want each Spark task to read. And with that, we get all the offset ranges from all the Kafka partitions between the last checkpoint and the latest Kafka offset. And we shuffle the list of offset ranges, and then we use the ideal split size. We compute it from the first step to basically take in subsets from this list of offset ranges. And the result of this is that each split will have very similar size of data to read from Kafka. And if you look at this example, the last split 5, it could be very small because it's the last one, but that's not a particular problem because in the worst case, we are just wasting one task if it finishes much faster than others. But for the rest of the split, it will take similar amount of time to finish. So the production job we are running now, having about using 30,000 splits with 6 terabytes of memory. So what I'm showing you here are the task running time for that job, the distribution of the task running time. So as you can see, most of the tasks finish in less than 30 seconds. But there are also some extreme cases that it takes about 3 minutes to finish. So there is still, it's not perfect, but comparing to the skew in the event size and QPS, it's much, much better. And in practice, we find it, works, perfectly. So I did some tests with, this new balanced Kafka Reader. It's able to support basically 20 times more higher throughput with imbalanced topics. So this work was done pretty much a year ago. We have been running this for a year, and our data size has grown a couple X, but it has been run so smoothly, and we haven't seen any major problem again. And of course, we were able to meet our SLA much better, which leads to happy customers and also happy engineers in the team. And if something goes wrong with any of the systems, Hive, Edge-based, Kafka, it's able to recover faster because in the case of recovery, we can basically throw more resource to the job and increase the parallelism. So you will be able to read with a much higher throughput. That's very useful in the case that we need to catch up with the Kafka stream. And we are in the middle of open sourcing this balanced Kafka Reader. It will be available soon. So now what? I guess I enjoy doing the work. I can get my paycheck from Airbnb every 2 weeks. I can probably buy a home in this ever-increasing market, and I can probably be happy afterwards. I want to share a trip I took a few weeks ago to Amsterdam with you. So I went to Amsterdam for the amazing city and the tulips and everything. When I started planning the trip, I went to Airbnb.com. I started looking for a place to stay. I found this place. It's a private room. It's nice and normal with a reasonable price. So I booked it for a couple of days, and then I flew to Amsterdam. I arrived at this place. It was hosted by this couple. Derek is Dutch, and Iman is actually from Egypt. So when I arrived at the place, Iman greeted me and showed me around. It's a 2-story apartment with living room and kitchen on the first floor. There were 3 bedrooms on the second floor. So even took me to my bedroom. It's actually next to the bedroom of the kids, and they actually very kind that they prepared the fruits, traditional Dutch waffle and everything for me. So a couple hours later, Derek came home from work. We had a really long conversation on different things like the history of Netherlands, why the Dutch people are so good at water management, and all of that, and how they met each other, and everything. So that's how I feel like really connected to the place when I was visiting. They are kind of the bridge between me and Amsterdam. And since its inception, Airbnb has made that happen for half a billion guests. And now when I look at this data flow again, it's not just microservices, Kafka, and the data warehouse again. I mean, it's essentially once of a lifetime trip for somebody that's going through this flow, or honeymoon trip for someone else, or maybe just a regular family trip for someone. So I think this is what really matters to me, and if this is something matters to you as well, join us, and that's everything. Thank you.
Thank you, Hao, for the insight on how actually you're doing things at scale. We have, quite a bit of time left. There are one speaker. I mean, there's a mic right here in the front. I have a bad back. I can't run around. So if you have any questions, please line up, and Hao can answer it. Go ahead.
Hey, thank you for this awesome presentation. So I actually have a question for the upgrade. That you upgrade to 2.3, that you rely on the product team to upgrade, or you upgrade by your data infra team yourself?
Sorry, can you speak a little bit louder?
The question was that when you're doing the upgrade, was it done in production, or was it actually doing you had a separate production or staging environment where you actually did the upgrade?
Right. So the process was basically, we create a separate branch. We upgrade the Spark versions and we resolve all the incompatibility due to the API changes and everything. And then we test the job in a separate environment to make sure it's correct. And then it goes into production.
My follow-up question to that would be, I mean, how much code changes actually required from changing all the RDDs to the data frames, because there's a high-level API. So did you actually have to go through, convert all the RDD operations and transformations into the data frames transformations?
Yeah, that's a great question. So we took two slightly different approaches depending on the job. For some of them, we took the quick approach. We just make sure it works with the newer Spark version. But for some of them, we did take the time to really upgrade them to data frames to make sure it has the best performance. And it's taking advantage of all the constant improvements. So what we did is actually we came up with a step-by-step guide for Spark upgrade. So it has like 10 steps, and every engineer can follow that step to go through and making the changes in the code base.
Are you planning to make that public so other people can benefit from it,
I think
a blog
so.
or an archive? Yeah. Okay, thank you. Next question, please.
Hi, thanks for the talk. Looking forward to seeing the open source version of that balanced reader. I've got a question about how does it handle resizing of the Kafka topics, repartitioning a Kafka topic, and you're resizing on the split on the consumer end. How does that work? Do you need to pause your consumer, or is it all happening dynamically on the fly? Or
it's pretty much everything on the fly. Let me go back to the slides. So if you look at
like the calculation of the offsets, is
Yeah.
that all happening dynamically if you repartition a topic or scale up or scale down?
Great question. So we're not doing anything with Kafka, right? So what we do is basically we get the latest the last checkpoint and the latest offset, and we get all of that, and we split them into chunks. And then for each chunk, it's assigned to a Spark task. So Spark task will basically get the offset and read that specific chunk from Kafka. So everything is pretty much on the Spark side.
Hello, thank you for a great talk. I would just like to clarify a bit. Where is the problem with imbalanced topics came from?
I'm sorry, I cannot hear.
Can you repeat the question?
A little bit louder, please.
Where is the problem with imbalanced topics come from?
Where's the problem coming from? Great question. So essentially, if you look at the current model of reading from Kafka, right? When you have two, let's say you have two Spark tasks that are reading from two Kafka topics. So each of them, like one task will read from one Kafka partition, and the other one will read from the second Kafka partition. What if the rate of the events in the Kafka topic are different, right? So one task will finish sooner than the other. And if there are extreme skew in the Kafka stream, then one is going to be finishing very soon, and the other one will take a long time to finish. But the Spark job will not be able to move to the next stage until it has finished all the tasks for this particular stage, which means if you look at the task running time, right? So pretty much all the tasks has finished except the last one, right? So they will be all waiting for the last one to finish so you can move to the next stage. And the resource that's occupied by the other executors will be basically idling. So that's a waste of a resource. And it's more than just wasting resources, right? When you have, let's say, in some cases the job is delayed, and we want to catch up with the latest Kafka stream, right? We want it to run faster, but in this case you cannot, because you cannot specify the number of tasks in Spark. It's determined by the number of Kafka partitions, which means if you give this job 2 times of memory vCore executors, it wouldn't help. It's still constrained by the particular Kafka partition that has the high QPS or event size. Does that make sense?
Why would you just consume 2 different Spark jobs from topic A and topic B? Or the Spark application depends on the data from the both topics at the same time?
Sorry, would you mind rephrase the question a little bit?
I mean, why would you just run 2 Spark applications, one to consume from topic A, another from topic B, and just run it in parallel?
Yep. That's a great suggestion. We actually considered that option as well. But the problem with that is that we are actually ingesting hundreds of Kafka topics, and it could be thousands in the next 1 or 2 years. The problem with that is we will be running hundreds of Spark jobs, and managing and tuning all of those jobs will be very difficult. So you can imagine all kinds of problems with some of the jobs going wrong, and someone will have to take a look. And with 300 or 500 jobs running, there is a high chance some of them will go wrong, like every day pretty much, right?
Okay, I got it.
But when you have 200 Spark applications running, you also have to deal with the fact that the Spark cluster manager now has to create JVMs for each and every one of the executors. So you somehow exhaust the effective parallelism. And I think if managing the skew is a lot easier than solving the other problems.
Yep.
Hi. So similar to the last question, right? In which stage you guys pre-compute the event size and decide the partitions?
At which stage it computes the split size and all of that?
Yes.
So this is a Spark streaming job, and it does that basically at the beginning of every batch.
Every batch?
Yes, at the beginning of every batch. You will basically talk to Kafka, get the latest offset, and then also get the last checkpoint. So we know what are the data to read, and then we'll split them into different chunks or splits, and then it will basically form this particular macro batch.
And after loading to HBase, you guys use Hive as a layer to query HBase, or you separately load from HBase to HDFS to query Hive?
So we actually have two ways to query the events after it's in HBase or Hive. So the more common way is basically we have an hourly job that dumps the events from HBase to Hive. So everybody basically can use Hive, Spark, Presto to query the data in the data warehouse. But for some use cases, people want to get access to the data more quickly. So we build a connector on top of HBase so they can actually do real-time query from Presto from HBase.
You use Presto or Hive for that? Presto.
Presto.
Okay, thanks.
Yeah.
Hello, thanks for the talk. I have two questions. The first one is there any duplication data issue in this pipeline? And if so, how do you resolve it?
Sorry, any what issue?
Do you have any how do you handle duplicates?
Duplicates.
Deduplicate.
Great question. So we definitely have, well, I mean, you will have duplicates, right? Because it's not like granted to be exactly once. With this job, we have checkpoints. If it fails in the middle of something, you will continue from the last checkpoint. So it's at least once. And the reason we are using HBase is essentially we are using that for deduplicating the events. Because in HBase, we're using the ID of the event as the row key, as part of the row key. So when the data is dumped from HBase to Hive, it's deduplicated.
I see. I have another question. So is there a scheduler for doing the split, data split, I mean the offset split? How often, if so, how often do you do that? And if you have a scheduler for that, does that create a single point of failure in the whole pipeline?
We don't have a separate scheduler for that. So all of this code is actually in the balanced Kafka Reader. So it's kind of an upgrade from the original Spark Reader, Kafka Reader in Spark. So yeah, there is no separate code base for that.
Every consumer can decide which split to read automatically without coordination?
The consumers?
So does that mean every consumer can decide which rank the offset to read without coordinating with other consumers?
They don't coordinate with each other. So basically, the assignment of the Kafka offset ranges are done when we are creating this particular macro batch. So the chunks are assigned to Spark tasks in the very beginning of this macro batch. Yeah, so there is no coordination. It's like more of a central model. So we do all the computation like what I described in this algorithm here, right? So everything is computed on the driver side, and then Spark will create the macro batch with the assignment.
Gotcha. Thank you.
Thank you.
Hello, great talk. I would like to know how are you managing the checkpoints of Spark? I imagine that you have multiple services running. Do you store that in HDFS, S3, or any other place?
Great question. So we actually managing the checkpoints using HBase. So yeah, HBase is a place we write all the Kafka checkpoints, and it's isolated by application name. So each application will have its own checkpoint set. Yeah, so that's how we manage that.
Hi, my name is Siva. So when we are using Kafka one-to-n reader, we are losing the event order, right? So is there any way to have both one-to-n reader as well as event ordering?
You mean having both of them?
Yeah.
In the same job?
Yeah. I mean, right now it's not possible as per current architecture. Is it possible doing that one also?
I'm pretty sure you can do that. I haven't tried, but I mean, it's essentially a different Spark stream, so I think you can definitely do that.
I mean, how is your HBase row key designed? Is it the timestamp and topic number, or?
Sorry, I didn't get the question.
How is your HBase row key designed? Is it
How do we
topic
design the
number and
HBase row key?
timestamp?
Is that Was your question how to design the HBase Roki?
Yeah, I mean, how did you design your HBase Roki? Is it based on the topic number and timestamp, or is it any other kind of thing?
Great question. I think the Roki was composed of the event name. What else? There was something else. And ID, I guess. Yeah. Yeah, I think mostly the event name and ID. Timestamp is a separate column, but it's not in the Roki.
I mean, when you load to Hive, do you directly query the HBase or use some H files to kind of move the data?
Right. So we basically create a storage handler in Hive, and then we create a HBase snapshot. We basically, do a copy of that snapshot into Hive.
Okay, we got last question. I
Thank
mean,
you.
there's a gentleman behind you, and we have to wrap up because you had two other speakers coming back.
Hi. Did you have to deal with different data set schemas across different topics? And did you do anything specific for your Spark HBase connector around timestamps?
Great question. So, I mean, in the piece of the pipeline I described, we don't do any specific schema handling because the job basically ingest the Kafka events into HBase. So all of that are Swift binaries. So the schema are dealt later when it has landed in Hive. Yeah.
And did you do anything around timestamps?
Sorry?
Did you have to do anything specific around timestamps with the Spark and HBase connector?
I don't believe so.
All right, thanks a lot. Give a big hand to Hao for his presentation. Talking about Amsterdam, incidentally, the next Spark AI Summit in Europe is going to be Amsterdam, so give some business to Airbnb. If you want to present, the CFPC is open, so please go ahead and present your proposal for presentation. Thank you for coming.